Okay, let us continue with this video. We are currently discussing about handbooks and reviewers. So I already mentioned about the blue book and green book of famous authors, but they are not textbook. They are not textbook, meaning you should use them after knowing the subject. So after, okay? But as I am saying, or as I have about to say, before I was cut off by the time limit, as I am saying, you don't need to wait for the semester to end. Okay? You can do your advanced studies. You can do your self-study. Okay? You can actually finish your self-study before we finish our course. Okay? Okay? Is there any law that would bar you, that would ban you, that would prevent you from doing that? I think there is no law. There is no rule. There is no regulation that would prevent you from doing that. Okay? So meaning to say, you can still use reviewers because it is possible for you to be able to self-study the textbook. Then afterwards, you can now you are now prepared to use the reviewers. Okay, you are not prepared because I always have an experience with the students who did not study the textbook and started to study reviewers. Sometimes they ask questions that are supposed to be already learned from the topics of the course. And why they are asking questions? Either they are absent or either they are advanced. Okay? Because why they are advanced? Because reviewers are advanced. That is the main reason why I do not want you to read reviewers first, because they are summary. And because they are summary, they are advanced because, for example, they can summarize 5 chapters into 1 page. Remember that. They can summarize 5 chapters into 1 page. And if you read that, of course, you can refresh your memory. You can recall, you can remember. If you already read the whole 5 chapters. But if not, what will you do? All the topics that you did not know, you will ask question from the professor. Okay? So that's why I would like you to first learn about the textbook. Okay? Okay? For what? For completeness. Because reviewers are so fast. They are so fast in discussing the subject. Remember, I recall when we review, for example, this subject. We review this subject 9 hours only. For 9 hours. Imagine we review this reinforced concrete design for 9 hours. That means 3 days. 3 days of 3 hours each. We finished reinforced concrete design. Remember that. Okay, take note of that. Meaning, the whole semester is compressed into 9 hours. And if you don't know anything about textbook, there's a problem. You will always have a problem. And that are our experience because we are the first graduate of this university. And beforehand, our single professor, our only one civil engineer professor died before we learn, okay? Something significant. Okay? So therefore, we graduated with almost with the amount of knowledge as a what? As an startup. As an startup. Okay? Okay? And then you will review for 9 hours the whole design. This is a design subject, and this is a professional course. Okay? Okay, so how hard is that? Therefore, you can use these handbooks and reviewers in order for you to be supported by these materials in your study as a support material. These are not the main materials. Definitely, they will help you. Handbooks is also faster and summarized compared to textbook, but a little bit more detailed than a reviewer. So a reviewer is, for example, 7 chapters. They can compress it into 2 pages and focus on what? Problem solving. That is the content of a reviewer. Okay? While handbook is the reverse. Okay? They will summarize, but they will focus on the summary, not on the problem solving. But they are, handbooks and reviewers are almost what? Compressed quantity, no, of the same topic. Okay? So therefore, you need to be guided by textbook, the authors. Okay. So let us continue. Okay. So we have our grading system. So we'll have our attendance, recitation, plus participation, quizzes, assignment, activities, projects, computation. Okay, because we have laboratory. Okay, because we have laboratory, we have what? Computation, something. Okay, and I already told you to what? To get a copy of an approved engineering plan. No? Okay, so get a copy of an approved engineering plan, complete, architectural, including plumbing, including electrical, including structural, or if it exists, including mechanical. So I already give you that assignment, and we have what? 8 professionals signing on these plans. I would like to get to ask you to get a complete set of plans. Why? Because we will use those later on, and also we will use the other 2 in our other subject, the engineering utilities. Okay, so okay, and I am always asking that, and those are being useful in order for you to feel it that you are what? Feeling what? Civil engineer. So let us feel like us a civil engineer. Okay? Let us practice to feel like a civil engineer. Okay? So first and foremost, this criteria for grading are of standard percentages, but they will what? They will change according to the specific of this current semester. So we don't know yet what will happen. If there are face-to-face, if there are available computer rooms. So there are available computer rooms, I will give more activities for you to do on the computer. So it will change. No? It will change, percentages will change, and they will change. But I will always give you a notice. Okay? Okay? I will notify you of the changes. Okay? For example, I will give an activity or extra activity or extra problem solving. And therefore, I will what? Notify you. Okay? That is fairness. Although I have my academic freedom as a teacher, I have also a practicing professional for what? Fairness. I want to be fair to everybody. Okay? So I am just what? Again, telling you that a teacher has the academic freedom to evaluate you, to grade you. Okay? Okay? Because we are doing this just like a judge, just like a referee. Okay? We are authorized to do this. Okay? So, even if as recitation, even attendance, I can judge it. Okay? I can judge it. Okay? So that's why I am judging your what? Eyes. Your eyes are looking somewhere else. Maybe you are not listening. But I also can judge that even if you are not looking straight in our monitor, in our front, I can judge if you are still listening. So we can have a what? A judgment on that. Okay. I am not saying teachers are always right. Teachers could be wrong, but still they have to judge. They have the authority to evaluate you. Okay. Any question about that? So be reminded. So not just what? Physically present during face-to-face, not just what? Zoom activated presence, but actually in your what? Mind, in your participation, you are present. Okay? So we are not on high school anymore. Actually, in fact, we are preparing you in this professional subject, in this professional course. Okay? Okay? So what about the title, Principles of Reinforced Prestressed Concrete Design? So that this title, we have to define those terms. What do you mean by principle? Principles are a set of ideas, knowledge, truths, proposal, okay, theories that governs a system. So it is a systematic thought. Okay, so that is what we mean by principle. Okay. What about design? What do you mean by design? So principles of reinforced and pre-stressed concrete design. Design. What do you mean by design? Design is the process of establishing the physical and other properties of a structure for the purpose of achieving the desired strength, serviceability, durability, constructibility, economy, and other desired characteristics. this is the definition of design in the context of civil engineering. Okay? In the context of civil engineering. Remember that. Because design in the context of computer engineering, okay, may be different. Design in the context of industrial engineering may be different. Okay? This is in particular true in the context of civil engineering. Okay? Because there is a what? Very specific use of terminologies, strength, okay, serviceability, durability, constructability, economy, and other design. Therefore, we can say design for strength, design for serviceability, design for durability, design for constructability. And actually, and other design characteristic, another design characteristic is what? Stability. In the old curriculum, in the old course, I am actually discussing 3 types of design. Design for strength, design for serviceability, and design for stability. But here we have so much, and in particular, this is for the whole civil engineering. And if we are talking of this course alone, principle of reinforced prestressed concrete design, we will only be able to discuss to you design for strength. Why? Because this is the basic form of design. Okay? Okay, so we will not be looking at serviceability, durability, constructability, economy, and other, and or stability. Okay? We will just use, but although that is only one, that is the most important one. Okay? Okay? And knowing that is so important because studying it by yourself would be very difficult. It is easier to study mathematics and science rather than design subject, okay? Because this involves practical, practice, actual. What can you see in the field? Okay? What are you doing in the field? Okay? That is not just mathematics. Okay? So, and the serviceability, durability, constructability, economy, and stability, for example, are type of design that you can more or less study by yourself. Okay? Serviceability, for example, is the next most difficult design area. So design for strength being the number one. Okay. Why it is possible for me to do so? Because I will follow what is being described in the policies, standards, and guidelines for civil engineering. Okay. CMO 92. So I will just follow it, and according to it, so whatever they mentioned there, I will follow. Okay. So definition for strength, what do you mean? Definition for strength means analysis to determine required strength. Okay, and design. So therefore, if we say design for strength, there are 2 components: analysis component and actually analysis point of view and design point of view. So there are 2 point of views when we talk of design for strength. Okay. So the point of view of analysis is what? Determination of required strength. And after determining the required strength, is that required strength less than or greater than the material strength. Okay, so that is the problem when we are going to analyze. Take note, analysis and design are two different things. This is the difference. Analysis determines required strength. After determining the required strength, it is compared to material strength or component strength or element strength. After comparing, is it greater than or less than? So we can decide, okay, afterwards what we have to do. So, okay, what about design? Design is the process of proportioning the size. Okay, what do you mean by proportioning? We want to find out the dimension. And after finding the dimension, that is actually dimension, we can find out the area, a size, okay, of the element. What are the elements that are we concerned about? Plain, pre-stressed, reinforced concrete elements. We want to find out the sizes of those elements and those materials involved in that, okay, in that component. Okay, that is what we mean by design. So design is the process of proportioning. Why? To have adequate available strength in order for our element not to fail under load, under given loads. Okay, so that's why we want to design. We want to design the dimension. We want to design the size. We want to design the element, okay, RC, reinforced concrete, or PC, prestressed concrete, in order to be able for this element to handle the load on the ground, on the application. Okay, so that is what we meant by design. So analysis and design, therefore, has opposite perspective, opposite point of view. So in analysis, we are given the dimension. There is a material and the material has dimension. Okay, we already know the dimension. What we are going to do is to determine if that dimension of the material can carry the load. That is what we call analysis. At the end of the computation, at the end of our analysis, we should be able to decide if this material, if this element, if this component can handle this load. Okay? If this size of the material. Okay? However, for the design, we are not given the dimension. We will find out what dimension, what area of the material, what is the size of the material that could handle particular. So the point of view is opposite to each other. So analysis is actually opposite in perspective, in point of view from design. Okay, that is a specific difference between analysis and design. So design for strength is the determination of load effects on members and connections based on principles of structural mechanics. So structural mechanics, take note. Structural mechanics meaning mechanics of deformable bodies and theory of structure. Okay, so remember to review, always review continuously. Okay, because this is your life, this is your living, this is a professional course. Later on, this will give you earnings. Okay, okay, this is why you are being hired as a civil engineer. This is the reason why, because these are the professional subjects. Okay, not because you are good at math, Not because you are good at science. Math and science are necessary, but those are preparation to be able to understand professional subjects. Okay? What about reinforcement? Because we have the word reinforced concrete. Therefore, we have reinforcement. We are reinforcing the concrete. There are several types of reinforcement. There are several methods of how to reinforce the concrete. Because concrete is not ideal, because concrete also have disadvantages, we want to reinforce in order to complement the disadvantages of concrete. Okay, and one of the most common, most utilized, most applied type of reinforcement is what we call steel bars, particularly deformed steel bars. Okay, okay, deformed steel bars, reinforcement bars, or rebar in short. Reinforcement bar, in short, rebar. It is equivalent to deformed steel bars. Okay? It is a steel bar, the surface of which is provided during hot rolling with lags or protrusions called deformation. So, meaning to say the surface of this have lags. Okay, so as you can, I will show pictures of this later on when we are talking about the materials. Okay, so that is the important thing about deformed steel bars. It is called deformed because the deformation is the name of the lags or the protrusions on the surface of the steel bar. Okay, it is not impossible to see plain steel bars without deformation, without protrusion. They are what we call plain steel bars. It is possible. They are still being used today, and mostly they are used in highways and some bridges. Okay, so there are still application of that, but about 95, 96, 97%, about even 98% of reinforcement. 98% of reinforcement we are using deformed steel bars or rebars. Okay. Okay, so what are other types of reinforcement? There are other types, there are so many types, and we will not be able to discuss all of them. Okay. This is a definition from PNS 49-2002. What is PNS? Philippine National Standard. Okay. But this is a very old document, 2002, 20 years ago. The newest document is PNS 49-2020, but I don't have a copy of that because getting a copy of these things cost money. We have to pay. We have to buy it. Okay, so we are still saving some some money for this purpose. Okay. What else? Concrete. So what do you mean by concrete? It is a composite material. Composite meaning it is a material that involves many other materials. Okay, composite. It is composed of many other materials. So composite material, which is composed of fine aggregate and coarse aggregate bonded together with a fluid cement. What do you mean by fluid cement? Also called cement paste. Because cement is in a powder form. When you buy it, it is in a powder form. You have to put what? You have to add water. So after adding water, you have to mix it up with the cement, and it will be a cement paste. So this cement paste is the chemical substance that would bond fine aggregate and coarse aggregate together. Okay, that hardens over time. So meaning to say, if you leave it at that, it will become harder and harder and become dry. Okay, okay, and hardening over time is what we call curing. Okay, curing. So if we say curing of cement, meaning we are hardening the cement over time. Okay, so cement paste, that is fluid cement, meaning cement with addition of water. What do you mean by fine aggregate? That means sand mostly. There are other fine aggregates, but sand is one example of it. And generally, the most popular fine aggregate is sand. What do you mean by coarse aggregate? We mean gravel. So cement, gravel, and sand. In addition, we have to use water. Okay, and mix them all together in a particular proportion called recipe. Okay, okay. What do you mean by reinforced concrete and prestressed concrete? Let us start with reinforced concrete, RC. It is also called RCC. What do you mean by RCC? Reinforced cement concrete, RCC. Also called ferro concrete. Ferro concrete, ferro meaning steel, iron, no? Concrete, so steel concrete, so meaning reinforced concrete. Because usually, we use steel as a reinforcement. That's why it is called ferro concrete. Okay. Reinforced concrete is a composite material in which concrete's relatively low tensile strength. Okay. Do you believe that? Do you believe that concrete has a relatively low tensile strength and ductility are compensated for by the inclusion of reinforcement having higher tensile strength or ductility? Tensile meaning what? Tension, no? Tension, well, you already know what do you mean by tension. So you can tension the, you can apply tension to the rubber band, okay? Rubber band. You can what? Stretch. You can stretch it. And therefore, we can believe that cement or concrete, okay? Concrete has a very relatively low value of tension stress, okay? Or tensile stress, okay? Meaning you cannot stretch the concrete, okay? In our country, when we say cement, in our local parlance, we say, simentado yung bahay nila. Cement. Okay? That is not correct. That is not correct. Worldwide, the correct term is concrete, not cement. Cement is the one that you have to buy from the hardware, and they are in the form per bag. Okay? Per bag, 40 kilos per bag. Okay? And they are powdery in form, in powdered form. Usually, the powder diameter is smaller than the sand. Okay, so cement particles are smaller than sand particles. Okay, so that is not a cement house or a cemented house. That is a concrete house. Okay, So in our local dialect, we say, simentado ang bahay nila. Simentado yung bahay nila eh. That is not a cemented house. That is a concrete house. Okay? So, because the concrete has a very low tensile strength, what can you say about the tensile strength of steel? Steel can be stretched. Steel has the property that can be stressed, okay? Because it is what? Ductile. Okay? Steel is a ductile material, okay? And in our strength of material or mechanics subject, mechanics course, we know that steel has almost equal characteristic when compressed and stretched. Stretching, tensioning, and compressing and steel almost has the same but reverse characteristic. Okay? And because of that, steel is a very good material. Okay? What about pre-stressed concrete? PC. Pre-stressed concrete, pre meaning before. Pre meaning before. Stress meaning the amount of load per unit area. Okay? That is stress. Okay? Pre-stressed concrete, okay, is a form of concrete substantially pre-stressed, substantially compressed. They are compressed during production and they are produced in factory. They are not produced on site. We are making reinforced concrete on site, but we are producing pre-stressed concrete in the plant, in the factory, in the manufacturing plant. So in the manufacturing plant, we are producing so many pre-stressed concrete and then what? Deliver it on site. Okay? In a manner that strengthens it against tensile forces which will exist when in service. In service meaning when used in the structure, right? As a structural component. Okay? So we will expect that the compression will be given by another form of material and usually steel component. Steel component is being utilized in order to compress the PC component. Okay. Later on, I will show you more on this. Pictures and concept, discussion, and even computation. Okay. So, we are going to end this particular video. Please answer the problem with the following questions. Number one, you are advised to search for the old and new CMO for the PSG. What do you mean by PSG? Policies, standards, and guidelines of PS Civil Engineering. You can go to the